Apple versus Windows. Well, this is not exactly what we are going to talk about in this video, but it is very similar to this, and it might be interesting as well. You might have heard names of various smart devices manufacturing companies. Smart devices like smartphones, smart watches, and even your laptops and desktops. But there are only few companies which produce the brains behind these devices. By brains, I mean the microprocessor or chips for short. So I'm going to list few of those companies, which are Intel, AMD, Qualcomm and MediaTek. So talking about Intel and AMD, they follow an architecture called x86 architecture. We are going to talk about this in a while. And Qualcomm and MediaTek follow an architecture called ARM architecture. So I have used this word architecture a lot of times. What does this mean? So by architecture, I am referring to design. So talking specifically about microprocessors, there are two types of designs. One is called CISC, CISC, and the another one is RISC, RISC. CISC stands for Complex Instruction Set Computing. Why is it complex? We'll see in a while. Before talking about that, let's talk about microprocessors. What are they? People often use processor and CPU interchangeably, but they are somewhat different from each other. You see the silicon chip on the board, right? This is what I mean when I say a processor. A processor consists of an ALU, a CU, and a register array, or we can say memory unit. So as you can see the definition on this screen, this is the definition of a processor. The whole silicon chip which is doing the job behind the scenes in your computer or your mobile phone, that is the processor. Now talking about CPU. CPU is a part of microprocessor. So microprocessor is basically the broader unit. We are not going to talk much about CPU, so let's get back to processors. So the question arises in our mind is, why do we even need processors? So at the end of the day, our software has to communicate with the hardware. And our software is written in languages like Python, Java, C++, Perl, JavaScript, and many more. But our hardware understands only binary, which is 0 and 1. Well, not even 0 and 1. It only understands on and off. That is why we need a processor, which can act as an intermediary between our software and hardware. But we have to make sure that it understands the languages of both. So that is why our processor is programmed with instruction set, or we can say our processors have instruction set. So do not take this instruction set lightly. It is very, very, very important. If our processor is not programmed, then we wouldn't have come so far. The technology we are seeing or experiencing or dealing with today wouldn't have been possible. It is all because we have smart processors, and that is due to instruction set. So this is the very, very important unit in processors. And this instruction set is the one which divides our processors in two categories. One which follow the CISC architecture and the another one which follows the RISC architecture. Now talking about CISC architecture, it stands for Complex Instruction Set Computing. So its name wasn't complex by birth. So it aims to complete tasks in few lines of assembly code as possible. So as we know, our processors are programmed in assembly languages. So the processor based on CISC architecture are like heavily programmed. So one single instruction can execute several low-level operations. So let's talk about multiplication. So they are capable of performing the multiplication operation in a single instruction. But when you are trying to perform such complex operation like multiplication in a single instruction, then it leads to more cycles per instructions. It means that you will take more time to do that operation. So that is why they result in high power consumption, more time, which is acceptable in our desktops and servers, but it is not suitable for small devices. Now let's talk about RISC, or Reduced Instruction Set Computing. So when this architecture came into picture, this is when the older architecture was named Complex Instruction Set Computing. Because now RISC uses small and highly optimized set of instructions. So you break heavier tasks into simpler operations, and each operation will execute and do the work for you. So it was now simple and it can execute quickly, so it can do the work in single clock cycle. Whereas in CISC, it used to take multiple clock cycles per instruction. So now they are optimized for low power consumption. They become the people's choice for mobile and small devices. So let's now get back to x86. We just talked about it. So the x86 follows the CISC architecture. So you might have seen all the Windows computer, they have this Intel Core i3, i5 or i7 written on them. Because x86 is the architecture used by Intel. It was started in 1968 by Robert Noyce and Gordon Moore, or Moore, I don't know the pronunciation. You remember the famous Moore's law? Yes, the same. So x86 processors are part of a larger system with multiple discrete components. This can lead to larger and thicker device designs. What does this mean? Let's see. So you might have heard about this expandable thing in all the Windows computer which have this Intel chip. So you can expand your RAM and GPU, CPU, everything. So because they have discrete components, so that is why they are scalable. So let's talk about ARM chips. So ARM chips are basically found in your phones. So they are system on chip, which means everything including your memory, RAM, CPU, GPU, everything is on the single chip. So have you ever heard that you can expand the RAM on your phone? No, right? Whereas you can do this on your laptop if it is Windows or it has an Intel chip. So yeah, that's the difference. So this system on chip thing allows for very compact and thin designs and less power consumption. That is why the ARM chips are very mobile friendly. So the biggest boom came when Apple announced their M1 chip. So this chip was going to power their all new MacBooks and phones and even iPads. And this followed the ARM architecture. Wait, but we talked about it is only suitable for mobile devices. But how can Apple take such a big decision? Well, the thing was that most instructions of this CISC architecture were just useless for day-to-day programming. But obviously, when you were doing heavy processing tasks such as video editing or gaming, then they are super beneficial. But for smaller day-to-day tasks, it wasn't much needed. So that is why Apple switched to the RISC architecture. and they partnered with the ARM company. So let's see how far the RISC goes. Well, meanwhile, comment your opinions and subscribe to the channel if you got to know something new. And yes, don't forget